Right, now for the next titration, we're going to do a titration using a pH meter, okay, or pH probe. Okay, this is a simple pH device that is used for accurately measuring the pH of a solution. Okay, it will give a digital readout, okay, of the pH. Okay, so at the moment it's reading 5.33. Okay, so before use of this, we would calibrate our pH probe by placing it into solutions of known pH. One must be a pH 7 and then either a pH 4 or a pH 9, so that the device can then generate the pH curve for the solutions. So we will place it in the solution, press calibrate, and it will come up with calibrate 7, press it again and it will come up for calibrate 4 or calibrate 9, and we would place it in one solution, calibrate it, rinse it off with distilled water, take it and place it in a second solution and calibrate it for the second pH. And this is called a two-point calibration. Now, what we're going to do, okay, is we're going to carry out this experiment, okay, in a beaker. The reason we're having to carry out this experiment in a beaker is that the pH, this type of pH probe is too wide to easily fit into the neck of a conical flask. But you can actually get narrow probes that will fit into the flask. Okay, or probes that will connect to a computer and give you a data logged complete curve of the pH. Okay. Now, what we're going to do, okay, is once again we're going to using our pipette and pipette filler, accurately measure out our 25 centimetre cubed of solution. Okay, in this case it's the sodium hydroxide. We're going to make sure that we check the meniscus at eye level, okay, adjusting where necessary, and then we're going to empty the solution into our beaker. Remembering that there will always be one tiny little drop left at the end which is calibrated for. Okay. Right. The way the pH probe works is that there is a little tiny glass sensor at the bottom which must be kept clean and must not be touched. Okay, that tiny little glass bulb is the sensor for detecting the change in pH. So it's important that when we are doing our titration, that glass sensor is in the solution. Now I have put the probe into the solution, you will notice that the pH reading has dramatically changed, way up to 11.9, which is strong alkali. We are now going to gradually, okay, add our solution of hydrochloric acid to this, noting that from the earlier titration that we had a titer of approximately 19.3, which gives us a rough idea of our endpoint. So we're going to gradually add our solution, making sure not to run the acid down the pH probe while agitating the solution. Now, you add the solution gradually in small amounts of a few mil at a time, purely because the pH probe has a lag. It is not an instantaneous change. Okay? It will take a few seconds for the pH probe to adjust and get a reading on the solution. So we add a few centimetres, we agitate it, okay, and we see what happens. And we keep going doing this until we get near to what we believe is our endpoint from our earlier titration with an indicator. which has given us a rough idea of where the end point is. If the device goes into auto sleep mode, which means it turns off again, just turn it back on. And then when we get roughly to where we think our endpoint would be, now bear in mind this time I started at 0, so we're talking somewhere above the, around about just before 19, we will switch to doing it drop by drop. Now if you're very careful, you can actually set the burette to add solution drop by drop, okay, while continually agitating, and you will start to see a drop off in the pH. Now towards the end will be very sudden, so we need to make sure that we are doing this in a very controlled drop by drop manner, okay, and we are aiming for a pH to stop around about a pH of 7. Now there is a little bit of variance, okay, so this one's currently reading 6.7, okay, because it's catching up with the lag, and that gave us a titer of 19.2, okay, and again you can repeat this, okay, and again to try and get some concordant results, okay, but it is a more accurate method than the indicator, okay, as there is more sensitivity in the pH meter.